In 2016, Dr. Schneider and Dr. Pekar published a research study called Bypassing Damaged Nervous Tissue. The goal of this project was to look for methods to restart nervous tissue that had been destroyed by demyelinization. As we learned in class, demyelinization is when the myelin sheath surrounding the nervous tissue it breaks down so that the nerves aren't able to deliver the information that they need to the nervous system. The doctors theorized that by recharging certain axons, the nerves would actually wake up and be able to deliver the information that it needed to do so. So the doctors began by simulating the membrane of the fibers using a saline solution and then charging the axons with between 20 and 30 volts of electricity. They found that if they shocked axons that were far away from the demyelinization sheath, but still close enough to be able to have contact to that information, they found that they could excite the nerves enough to get some control over the axon so that it would be able to wake up and deliver the information that needed to do so. So if you look at this diagram, this is kind of what they were following. They would electrocute this top line right here so that they would have access and somehow wake up the line down here. So this project is very important to a future in having a job in a medical field, just because the nervous tissue, it is very important for any growth that our body needs. So if we could recharge those nerves that are no longer functional, if we can deliver that information, then we have full use of our parasympathetic and sympathetic actions, that fight or flight system that we have. It also is going to make sure that if our patients have multiple sclerosis, we're able to contradict any problems that they may have. My only problem with this study is that I'm wondering if maybe there isn't a way to simulate the myelin of the sheath. So instead of putting more electricity into the body by charging a different axon, kind of like doubling the power that it has, you're able to simulate a myelin sheath so that the nerve bundles, they don't need any more electricity. They have what they have, but that electricity is able to stay in it, kind of like a wire circuit for the veins. I'm also wondering if maybe you double the electricity of already dead axons, then they would wake up themselves. They wouldn't need to have another axon pick up on their energy. Otherwise, the results of the study were very well done, and they're still doing work to try and figure out another way to fix the nervous tissue.